Hello, in this lesson we're going to study combinations of functions, including both arithmetic operations and compositions. We will learn how to combine functions in different ways and how those combinations affect the output and the domain. This is an important foundation for more advanced topics, so we will take it step by step. In this section, we will learn how to add, subtract, multiply, and divide functions. We will find composition of two functions and use combinations and compositions to model real-world situations. The main goal is to understand how functions interact with each other. Let's begin with an arithmetic combination of functions. If we have two functions, f of x and g of x, we can combine them just like algebraic expressions. We can add them, subtract them, multiply them, and divide them. The key idea here is that when performing these operations, we replace each function with its expression, then simplify carefully. Here's an important reminder. When dividing functions, say f of x over g of x, we must make sure that the denominator is not 0. So always check for values where g of x is equal to 0 and exclude them from the domain. Now let's apply those operations. Here we are working through examples step by step. Let's focus on substituting the full expressions into each function. Make sure we keep our parentheses, this is very important, and then simplify very carefully. Don't rush the algebra here. Most mistakes happen when parentheses are dropped too early. Always check for restrictions, especially when dividing or working with expressions that could equal 0. This slide is really about practicing careful algebra with functions. Now we move on to composition of functions. Composition means we take one function and plug it into another. We write f of g of x. What this means is that we first evaluate g of x, and then we plug that result into f of x. Here it is very important that you understand that order matters. F of g of x is not the same as g of f of x. Switching the order usually gives us a completely different result. Think of compositions as a two-step process. Whatever is inside happens first. Now let's carefully work through this example. We are given f of x is equal to x squared minus 9, and g of x is equal to the square root of 9 minus x squared, and we want to find f of g of x. Step 1 is to substitute. We replace every x in f of x with g of x. That means f of g of x is equal to f of the square root of 9 minus x squared. Step 2 is to apply the function. That means we get f of g of x is equal to the square root of 9 minus x squared minus 9. This is where many students make a mistake. This is not the same as squaring the entire expression 9 minus x squared. Instead, we are squaring a square root. And when a square root is squared, they cancel. Step 3 is to simplify. The square root of 9 minus x squared is equal to 9 minus x squared. So 9 minus x squared minus 9 is equal to negative x squared. Step 4 is to determine the domain. The restriction comes from the square root. The expression inside the square root must be greater than or equal to 0. So 9 minus x squared must be greater than or equal to 0. Solving this means we get x is between negative 3 and 3, including negative 3 and 3. The final answer here is that the function f of g of x is equal to negative x squared with a domain of negative 3 to 3, including negative 3 and 3. When working with compositions, always substitute carefully, simplify step by step, and always check the domain, especially when square roots and dividing by a function are involved.